So today we're doing problem 37 out of the related rates problems. So what the problem gives is a triangle that looks kind of like this, with a 12 meter one side, angle of theta, and a 15 meter other side. And then we have an unknown x value side here. So what we do know, let's separate this off, and the things we do know are that d theta dt is equal to 2 degrees per minute. We also know that theta at this snapshot in time that we're going to solve for is 60 degrees. And so what we're solving for here is when theta is 60 degrees and theta is changing at 2 degrees per minute, how will that impact our x and what rate will that be changing at? That's what we're solving for. And so our unknown then is dx dt. That's our unknown. So what we can do first is rewrite these as their radian forms. So 60 degrees in radians is pi over 3 radians. And then 2 degrees per minute, that's going to be pi over 90 radians per minute. Pi over 90 radians per minute. So in order to establish a relationship, we can use law of cosines. So law of cosines looks like this. C squared equals a squared plus b squared minus 2ab cosine theta. Now what we'll do is we'll start plugging in some variables. So with x here, we can change c to x. And so x squared, 12 can be a, and that'll be 12 squared plus 15 squared is b, b is 15, minus 2, 12 times 15 cosine, and we'll leave that at theta for now. We're going to use this equation, this most recent one, to derive and use later, so I'll put an arrow over there, so we'll use that later. So now we're going to start plugging in our values, all of them. So now that we have cosine theta, as that's not plugged in yet, so I'll plug in our number is pi over 3 radians. So x squared equals 369 minus 360 times cosine of pi over 3. And then x squared, we can simplify this down all the way to 369 minus 360 times 0.5, which is cosine of pi over 3 radians. And so now that's going to give us x squared, if we simplify that all down, it's going to be 189. And that means x is the square root of 189, which can also be simplified down to 3 over square root of 21. Now what we can do is do the derivative of this equation. So that's going to be 2x times dx dt equals, and then 360, the derivative, 369, the derivative of that is 0, minus 360 times cosine of theta. That's going to be 360 times the derivative of cosine that we have here. That is negative sine of theta. And so next what we can do is change that all to dx dt. And by moving this 2x, we'll eventually divide over 2x. That's going to be 360 times sine of theta. I realized I made a mistake. We also have to do d theta dt over here and over here. And then for this one, we'll divide over 2x that we have from this one. So now, since dx dt is our unknown, we'll put that over here, we'll keep that over here, and then we'll start plugging in all of our values. So 360 times, that's going to be a square root of 3 over 2 for the sine theta of pi over 3. And that's times pi over 90, which is equal to our d theta dt that we have right here. So we'll plug that pi over 90 in. And then we're multiplying over 2x, or dividing over by 2x. So then 2x, we just figured out our x is here. So that's what our x is, and then 2 times 3 square root of 21. And then through some calculation, because we can just simplify this all out, that's going to give us our answer. Dx dt equals 0.3958 meters per minute. And that's when theta equals 60. Equals 60 degrees, or pi over 3 radians.